Welcome to the lecture series of embedded system. Code is KOE 062. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to cover the second lecture of this series, and the topics I am going to cover in this lecture are the build process for embedded systems and structural units in any embedded processor. So, let us go into details. So, what is a build process? The process which converts the source code to the executable code, that is known as the build process. The build process for embedded system is very much different from the general applications, because the code to be run on the embedded system is written on one platform, that is general purpose computer, and executed on another platform, that is known as the target hardware. So, this is the difference. So, in other systems, not in the embedded system, this is the different fact, that the code made on the one platform is not executed on another platform. So, the platforms are same in that case, but in case of embedded system, the code to be run on embedded system is written on one platform and executed on another platform, which is the target hardware. So, an embedded system would also use the tools such as compiler, linker, locator, debugger to perform the entire build process, and these tools would be a part of larger IDE, that is integrated development environment. So, let us go into details of these. So, what is a build process is depicted by this diagram. There is a source code, compiler, linker, locator and executable code. So, first of all, our source code will go through the compiler, which will convert it into the output files, and those will go into the linker. The linker, after linking all the codes, will send the output to the relocator, and at the end, after relocating and making a single output file, that executable file will be called as the executable code. So, basically in the build process, the main three parts which are working are compiler, linker and locator, and correspondingly these are the three processes, that is compiling, linking and locating. So, let us understand these processes one by one. So, the process of compiling is done by the compiler. The compiler takes the input as the source code files and gives output as the multiple object files. So, here input is the source code files and output is the multiple object files. Compilers for embedded systems are essentially cross compilers. What are these cross compilers? So, a compiler which produces the executable code to be run on a different platform, that is known as the cross compiler. If the executable code is to be run on the same machine, then it is called the native compiler. For example, C++ is a native compiler. Okay. But in case of embedded systems, the compilers used are the cross compilers. So, while we are using the cross compilers, the programmer has to select the target processor for which the code has to be generated. This is the difference. So, while using the cross compilers in the embedded system, we have to select the target hardware. So, what is the object file? So, in the previous slide I said that the input to the compiler is the source code files and the output is the multiple object files. So, what is this object file? So, the contents of the object file depends upon its format, and there are two formats available for any object file. First is the common object file format, that is COFF, and another one is the extended file format, that is the ELF. Object file generally have this structure. What is the structure? Header is there, text, data and BSS. What are these? Header describes the sections that will be contained in the object file. Okay. So, this is the heading, basically this is the heading. Text, it contains all the code blocks. Okay. So, all the code blocks are available in this section. Data, it contains all initialized global variables and their values, and BSS is all contains all the initialized global variables only. So, this is the format of any object file. Now, what is linking? So, after compiler, what was the output? Output was the multiple object files. Now, the next step is linking. What the linker is doing? The linker takes all the input as the multiple object files. So, all the multiple object files which were produced by the compiler are working as the input for the linker, and now the linker gives the output as a single object file, and this single object file is known as the relocatable code. So, basically what we saw that first of all there was the compiler, yes, source code was sent to the compiler. After compiler there was a linker. The compiler produced multiple object files, okay, object codes. Now, this multiple object files went to the linker, and linker produced single object file, yes. So, that is the relocatable code. Output of the compiler is multiple object files. These files are incomplete. Why these files are incomplete? Because these files contains the reference to the variables and functions across multiple object files which need to be resolved. So, there must be a standard single file not containing the references to the different files. The object of the linker is to combine these multiple object files and resolve the unresolved symbols. So, what the linker does? Linker merges the various sections like text, data and BSS. I talked about the various sections present in the object file. One was the header, there was the data, then there was the text and the BSS. So, what the linker does? Linker combines all the values present in these different sections and produces a single output file which is having these sections, but a combination of the various multiple input files. The output of the linker will be a single file which contains all the machine language code from all of the input object files that will be in the text section of this new file, and all the initialized and uninitialized variables will reside in the new data section and the BSS sections respectively. So, in this way the linker links, or we can say it combines all the multiple input object files. What is the role of the locator? The process of relocating is carried out by the relocator. The relocator takes input as the relocatable code produced by the linker and gives output as the final executable code. This output is a binary executable file which is called the hex code. So, finally, the output which is produced by the locator, it is known as the hex code. The locator needs to be given information about the memory available on the target processor. The locator will use this information to assign the physical memory addresses to each of the code and data sections within the relocatable program code. So, the locator must be having the information about the memory available on the target processor. Yes. So, as we know that the target hardware is different in case of embedded processors. So, the locator must be having the information of the memory available on the target device. So, and the locator will use this information to assign the physical memory addresses to each of the code and the data sections. So, we know that for storing the data and the code sections, the memory is required. So, locator will do what? It will allocate certain memory required by the code and as well as by the data sections. Finally, it produces an output file that contains a binary memory image that can be loaded into the target processor's ROM. Okay. So, finally, a binary memory image will be obtained as a final output and that is loaded into the target processor's ROM. So, this is known as a ROM image file. So, in this way, when we went through the build process, so we can say there were the 3 steps, that is the compiling, linking and relocating. So, these 3 steps completes the build process for embedded system application. Now, when we talk about the embedded system design, for developing the embedded system hardware, we can make the choice between the two, that is the microprocessor and the microcontroller. So, what is microprocessor? Basically, it is the processor on a single chip containing the arithmetic logic unit and the that is the ALU, register set and the control unit. It does not control the input, it does not contain the input output devices or any memory units on a single chip. But when we talk about the microcontroller, it contains all the memory memory units or the input output units on a single chip along with the CPU. So, when the CPU input output devices and the memory units, these are all available on a single chip, that is known as the microcontroller. So, when we compare the designs based on these two, that is the microcontroller and the microprocessor, what we will find, there are certain differences between these two systems. So, the CPU is the standalone, RAM, ROM, input output and timer are separate. In case of microcontroller based system, CPU, RAM, ROM, input output and timer all are on the single chip. Designers can decide the amount of RAM, ROM and input output ports. In case of microprocessor and microcontroller, fixed amount of on chip RAM, ROM and input output ports are available. So, high processing power is the characteristic of microprocessor based system and the low processing power is the characteristic of microcontroller based system. Another important feature is the high power consumption in case of microprocessor and low power consumption in case of microcontroller based system. Typical systems based on the microprocessors are 32 or 64 bit and the typical systems based on microcontroller are 8 or the 16 bit systems. Microprocessor, as we all know, with that it is a general purpose system and microcontroller is the special purpose system. Microprocessor is less reliable, but since microcontroller based systems are dedicated to certain applications, so these are highly reliable. The examples of microprocessors used are 8086, 8085 and the examples of microcontrollers used, a very common example is the 8051 microcontroller. The various structural units available in the embedded processors are internal buses, address bus, data bus and there are many more which we will see in the subsequent slides. So, what are the internal buses? It internally connects all the structural units inside the processor, which can be 8, 16, 32 or 64 bits. Next, what is the address bus? Address bus carries the address from the memory address register to the memory as well as the input output devices and the other units of the system. So, basically address bus will contain the address of the devices. Now, the data bus. Data bus will carry the data from or to the address control bus. It is an external bus to carry the control signals between the processor and the memory devices. So, this is the role of the data bus. Now, when we talk about the bus interface unit, it is the interface unit between the processor's internal units with the external buses. So, this is the bus interface unit and it plays a very important role in the execution. MAR is memory address register. It holds the address of the byte or the word to be fetched from the external memories. So, as the name is suggesting, it is related to the memory addresses. MDR, memory data register, it will contain the byte or the word fetched from or to the external memory or the input output address. So, this is the role of the memory data register which will contains the data bytes or the words. What is the role of the program counter? abbreviated form as PC. It holds the memory address of the next instruction to be executed. In any of the microcontroller or the microprocessor we talk about, program counter has its universal role, and the role is to hold the memory address of the next instruction to be executed. In any case, whenever you will read the value from the PC, you will always find the value of the address of the next instruction to be executed. So, we should note this point, that PC will always hold the address of the next instruction to be executed. What is the stack pointer? Stack pointer is a we can say it is a pointer for an address of the top of the stack. It will always hold the address of the top of the stack. Since the stack is what? Stack is a continuous memory locations, or a stack of the memory locations we can say, which works on the basis of last come first serve basis. Okay. So, this is how the stack works, and this stack pointer points to the uppermost location of the stack. Instruction register, it takes sequentially the instruction opcode received at the IR pass. Instruction register passes it to the processor CPU, that is the control unit. So, it is decodes the and instruction register will hold this instructions, and the instruction decoder will decode these instructions opcodes received at the instruction register. So, instruction, and what is the role of the instruction queue? It is a queue of instructions, so that the instruction register does not have to wait for the next instruction after one has been carried out. So, for example, in 8086 we have an instruction queue, and what is the role of that queue? That it contains a set of certain codes, opcodes, and one by one those opcodes are executed. So, basically the role of the any instruction queue is to prefetch the certain opcodes from the main memory, so that the time is saved. So, basically this few opcodes are prefetched from the main memory, and those are processed sequentially. Another very important structural unit is arithmetic and logical unit, and this unit is basically meant for executing the arithmetic and logical operations. Floating point processing unit is another important component, and it is available in the advanced applications in which there is a role of floating point arithmetic. Floating point register set, that is, it is dedicated for storing floating point numbers in standard format and used by the FPPU. So, this FPPU will use this register set, that is a floating point register set, for the various operations for its data and stack. What is the role of control unit? It controls all the bus activities and the unit functions needed for processing. So, this is how the control unit works. It controls all the processes going on inside the bus activities and the various units available inside a embedded application. What is the role of the memory management unit? MMU. So, because memory plays an important role in any embedded system application. So, how to manage the memory, how much memory should be allocated or deallocated at different instances of the processes, this is very important. And for managing all these activities related to the memory, we need memory management unit. There are various we can say there are various ways of managing the memory, that is, a memory segmentation is there, paging is there. So, we will study all these processes in next lectures. It manages the memory such that the instruction and the data are readily available for processing. Another important structural unit is application register set. So, as we know that what is register? Register is something which will store the data. Yes. So, it is a set of on-chip registers used during the processing the instruction of the application program of the user. So, all these register sets are used for storing the various data, or we can say for configuring the various processing units inside an application. What is the role of instruction cache? It sequentially stores, like an instruction queue, the instructions in the FIFO, that is the first in first out. Okay. So, what is the cache memory? The cache memory, you can say, is the instruction cache, means that the a set of certain opcodes or the set of certain instructions are stored in the cache, and which are sequentially executed, and the instructions are served in the first in first out basis. That is, the instruction which was firstly added in the instruction queue are executed before the next instructions. What is the data cache? It stores the prefetched data from the external memory. So, data cache is what? Data cache will contain few the data units which have been prefetched from the external memory. So, in this way the data cache is used to prefetch and to store the external memory data. For these instruction cache and the data cache, these are used for the smooth functioning, for the smooth processing of the processes inside an application. Prefetch control unit, it controls the prefetching of the data in the instruction cache and data cache in advance from the memory units. The instruction and the data are delivered when needed to the processor's execution time. So, prefetch control, what is the role of the prefetch control unit? It will basically control that what data has to be prefetched, what the instruction has to be prefetched, and these instructions and data have to be stored in the instruction cache and data cache respectively. And when these instructions and data are to be processed, and when they are to be stored and to be transferred to the processor's execution unit. So, all these control functions for the data and the instructions, all these are controlled by the prefetch control unit. So, what is the register window? It consists of the subset of registers, with each subset storing static variables and status words of a task or the program thread. So, what are these terms? Like when we talk about the register window, so when register is what? Register will contain certain data inside it, and or we can say it is used to configure certain operations. So, register window is something which will contain the subset of registers, and here each subset is storing what? It is storing static variables, okay, the variables which are not going to be changed. These are the static variables, and the status words. Yes, status words means which will define certain conditions of the various processes of the various tasks or the program's thread. So, in this way the register window is defined. Another important structural unit is the advanced processing unit. It is used for multi-stage pipeline processing, multi-line superscalar processing to obtain the processing speed higher than one instruction per clock cycle. So, for a general system, the processing speed is one instruction per clock cycle. But when we talk about the advanced applications, when we talked about the advanced operations, then we are talking about the multi-stage pipelines. So, pipelining I have already explained that a certain set of instructions or the certain data is opcodes are already prefetched from the main memory, and it helps in smooth functioning of the various processes, because these opcodes which have been prefetched from the main memory, these are executed sequentially and at a higher speed. So, the processing speed of the various operations present in the embedded system applications is increased, and it is rather much higher than one instruction per clock cycle. So, in this way the advanced processing units are very important part of any embedded system. So, here we and the last structural unit is atomic operations unit. Basically all the main processes are broken into number of processes, number of processor instructions called atomic operations, and these operations are finished before any interrupt of the process occurs. So, in this way all the large operations or the processes, we can say, they are broken into the smaller processes and they are executed at a much higher efficiency and at a much higher speed. So, today we talked about the very important structural units. So, that is all for the day. Thank you.